So this is page 659. And let's start with question 2. Explain how you know that triangle ABC is similar to triangle DEC. Okay, so let's flip back to that triangle for a second. How do you know that this big triangle, ABC, is similar to this littler triangle, DEC? Okay, take a second to think about it. Okay, if you said that they're similar because they both have two angles congruent, then by angle-angle similarity they're congruent, you are correct. So let's go back and let's write down something similar to that. Triangle ABC is similar to triangle DEC because both triangles share a 45-degree angle and they both have a 90-degree angle. Therefore, the two triangles are similar by angle-angle similarity theorem. Great. Okay, question number 3. It says measure each of the sides of triangles ABC and DEC in millimeters. Record the approximate measurements. Okay, question 3 says we're going to measure each of the sides of triangle ABC and DEC in millimeters. Record the approximate measurements. Okay, so let's go back to our triangle here and let's get some measurements going. Your measurements are going to be different from mine because you drew your side in a different place, and that's okay. Just make sure that you measure how long each of these sides are. So it looks like AB is 10.2, and I'm going to write it in millimeters. So it's 102 millimeters, because that would be 10.2 centimeters, right? And this side is also 102, so CB is 102 millimeters. Let's get CE. This one I wrote as 65. This is 65 millimeters. Let's get this long side here. I got 144. I got 144 millimeters, and then CD I got as 92. Okay. I think those are all the sides. So, okay, so let's go back and record our measurements. I got side AB, side BC, and side AC. And side AB I found was 102 millimeters. Side BC I found to be 102 millimeters also. And then AC I got as 144 millimeters. And then when I drew my other triangle, DEF, so I've got DE, and I've got EF, and I've got DC. So DE, oh shoot, I didn't measure DE. Let's get DE. DE I got as also 65. Well, that makes sense because it's a 45, 45, 90 right triangle, so those should be the same. So I got DE as 65 millimeters, and I got EC. No, I should have DC and EC. This should be EC. EC was 65 millimeters. And DC I measured as 92. Okay, there's a reason for why we're taking down all of these measurements, and we're going to get to it in a second. Okay, so let's read this little paragraph and then we'll do question 4. You know that the hypotenuse of a right triangle is the side that is opposite the right angle. So you can draw a little picture of a triangle here, right? So here's the right angle, right? There's a little arrow, right angle. And then opposite on the other side, right here, that's the hypotenuse. Okay, that's the longest side. In trigonometry, the legs of a right triangle are often referred to as the opposite side and the adjacent side. Okay, so it depends on what angle you're using. The opposite side is just the side that's on the other side of the triangle, and then the adjacent side is whatever is connected to it. Okay? So the legs of a right triangle are often referred to as the opposite side and the adjacent side. These references are based on the angle of the triangle that you are looking at, which is called the reference angle. The opposite side is the side opposite the reference angle. And the adjacent side is the side adjacent to the reference angle that is not the hypotenuse. Okay, this is important. It cannot be the hypotenuse. So we're going to go back to our triangle. We're going to identify the opposite side, the adjacent side, and the hypotenuse using angle C as the reference angle. Okay, so we're going to put opposite, and let's put for triangle ABC, and then we'll put triangle DEC. Triangle DEC. Okay, so let's go back and look at the triangle that we drew. Okay, so C is my reference angle right here. This is the reference angle. Okay, so from the reference angle, the side opposite is the one that's not connected to it, right? So this angle is formed by this side and this side, so it's the side that's not part of the angle. So this is an opposite side, and this is an opposite side. Okay. Now, the adjacent side is the one that's connected to the reference angle, but it's not the hypotenuse. Okay. So this is an adjacent side, and this whole thing is an adjacent side for the big triangle. And then the hypotenuse is going to be the one that's opposite the right angle always. So this is a hypotenuse, and then the whole thing is a hypotenuse of those two triangles. Okay, so let's go back and identify those sides. So let's go in order. Which side is the opposite side to angle C of triangle ABC? Okay, take a moment to think about it. Which one is the opposite side? Okay, so the big triangle ABC, the opposite side is AB. Okay, so side AB. Okay. Which side is the adjacent side? Is the adjacent side to angle C. Okay, think about it for a second. Which one's the adjacent side of ABC? That's the big triangle. Okay, let's take a look. The adjacent side is BC, this long side right here. Okay, and then the last one, which one is the hypotenuse? The hypotenuse of triangle ABC is, okay, which side is the hypotenuse? Let's take a look. Hypotenuse is going to be AC. The hypotenuse of triangle ABC is AC. All right, now let's try it for triangle DEC. I'm gonna write them all down and then you guys are gonna fill them in. Side blank is the opposite. I'm just gonna start abbreviating, okay? Side blank is the adjacent, and the hypotenuse of triangle DEC is blank. Okay, let's see if we can get all three of these right. Okay, write down what you think is the opposite side. Okay, now let's look at the little triangle. We got triangle DEC. The opposite side is DE. Okay. Give yourself a little point if you got it correct. Okay. Now, write down which side is the adjacent side of angle C. Right? Okay, let's check. Angle C, the adjacent side is EC. Okay. If you put EC, give yourself a little check. All right, and then the last one, write down which side is the hypotenuse of triangle DEC. Okay, let's check. The hypotenuse is always opposite the right angle, so the hypotenuse will be DC. Okay, if you put DC, give yourself a little check. All right, now that's page 659, and now you can identify the opposite, adjacent, and hypotenuse of a right triangle.